let's talk a little bit about exponential growth models. Now, let's say that we have a very simple growth model where, let's say we start off with, I don't know, 10 bunnies, okay, 10 rabbits, and every year their population doubles, okay, pop doubles every year, okay? So at first it's 10, then it's 10 times 2. Then we take what we had last year and we double that. So we get 40. And then we take what we had the year before and we double that. And so on and so forth. Well, what's happening? Well, we have this starting value. And then we multiply by the same thing every period, in this case, every year. So we have our starting value, we have our thing that we multiply by, and then we have whatever time period that's going to happen over. In this case, it's going to be every year, okay? So if I make this 1, then this is 10 times 2. If I make this 2, this is 10 times 2 times 2. So that's this model right here. This is our start. This is our base. This is the thing we're multiplying by. This is usually time. And this is what we end up with, okay, after we've multiplied over and over and over again. So another example that happens a lot is something that grows by a certain percent. So let's say like it's interest, and every year your investment grows by 5%. Well, that's 0.05 as a decimal. So what we do is we take our initial investment. Let's say our initial investment is $1,000. And then we do 1 plus whatever percent we're increasing by. And then we're going to multiply by this every year. So 1,000, and then 1,000 times 1.05, and then 1,000 times 1.05. Multiply that twice, and then we would keep going like this. And you could do the same thing if you were decreasing by a percent. Let's say that we are losing 5% on something every year. Something is depreciating, like your car or your house. So let's say our car is worth, let's say $40,000, okay? And then instead of increasing by that 5%, we're going to decrease by 5%. So 40,000 times 0.95, 40,000 times 0.95 times 0.95, and so on. And remember, when we're multiplying by 0.95, we're getting smaller instead of bigger. So this would be 40,000, the thing we're starting with. Our base would be 0.95, and then t could be time. And then we've got stuff like half-life, where we're cutting something in half every year. So I don't know, we start with 100, and then it's times 1/2 to the t. Now, of course, that would be if it was every year. We'll get into more complicated half-life models later. But this is the idea. You start with something, and then you multiply it by 1/2 over and over and over again. So this is the basics, and we'll get a little more complicated as we go.